Hello friends, my name is Kapil Sukhdev Bobde and today we are going to start a topic of a geography subject. The topic is continental drift theory part 1 that is useful for the Army, Navy, Air Force examinations. So before starting we need to know about some concepts that is related to understand the tectonic process. So for the tectonic process the first theory is the continental drift theory. First theory is the continental drift theory. So this theory refers to the movement of the continents relative to each other. Relative to each other. First theory, the continental drift theory. Second is polar wandering theory. This is similar to continental drift theory. Continental drift theory. And the polar wandering basically relative movement of Earth's crust and upper mantle with respect to the rotational poles of the earth. Next is seafloor spreading theory, SFST. So this theory describes the movement of oceanic plates relative to one another. The next theory is plate tectonics. So plate tectonics basically the movement of lithospheric plates relative to each other. And the last one is convection current theory. The convection current theory forms the basis on the sea floor spreading theory and plate tectonics theory. So this explains the convection current theory explains the force behind plate movements. Okay friends, the next is this. So we can see the image. This image is showing the 7 different continents of the earth: Asia, Europe, Africa, Australia, Antarctica, North America, South America, and the oceans. So oceans are Pacific, Atlantic, Indian, Northern or Arctic or Southern Antarctic Ocean. This is the present image of the world. But before thousands of millions of years ago, about 225 millions of years ago, the earth like this. Amazed? Yes, amazed. So we can see in this image all the continents are united. All the continents are united. You can see the North America is joining to the Africa, South America is joining to the Africa, Antarctica, India, Australia, all are on one place. They all are in a one piece. So this big landmass before 225 millions of years ago, the earth was a single piece. The lithosphere on the earth, the continents was in a single piece, is called Pangea, the great continent, the major continent. And the ocean water surrounded by this Pangea was called Panthalassa. The mega ocean was called Panthalassa. The mega ocean called Panthalassa. So next, the continental drift theory. Who proposed the theory? So the Alfred Wegener in 1912 proposed the continental drift theory. And the theory of continental drift deals with the distribution of oceans and the continents. Oceans and the continents. So according to this theory, there are 5 oceans and 7 continents. And according to this Wegener's continental drift theory, all the continents were one single continent mass called supercontinent, and is Pangea. That is Pangea, and a mega ocean surrounded this supercontinent is called mega ocean, known by the name of the Panthalassa, as we seen in the previous image. Next is according to the theory of the supercontinent, Pangea began split some about 200 millions of years back. And the Pangea first split into 2 big continental masses. 2 big continental masses known as Gondwana land and Laurasia. So Gondwana was the southern part of the Pangea and Laurasia was the northern part of the Pangea respectively. And the latter Gondwana and Laurasia also continued to break into several smaller continents that exist today, like Asia, Africa, Australia, Antarctica, North America, South America. So, need to know the stages of the continental drift. So, the continental drift goes in the 5 stages. The first stage is known as the Permian stage, and that is about 250 million of years ago. So in this stage, the all landmass was united and called Pangea. The united landmass called Pangea, and this Pangea was surrounded by the Panthalassa, the mega ocean. In this colorful image, you can see the parts of the Pangea of different continents. So during the Carboniferous period, in which a supercontinent Pangea was surrounded by the mega ocean called Panthalassa. This was also the Carboniferous period. Next is the second stage, Triassic age. Triassic age, that is about 200 million of years ago. In this stage, you can see the forces separating these parts of the Laurasia, means the Laurasia and Gondwana land are clearly formed in the second stage, Triassic age, due to the internal and external forces on the earth. Laurasia, the northern part, and Gondwana land, the southern part. These 2 parts. So around 200 million years ago, flights of the continents took place. The continents are going to take the current position, the continents begins to drift gradually and broke into pieces. You can see the pieces of the different color pieces, and Laurasia and Gondwana land, and India was the part of Gondwana land. India was the part of Gondwana land. So in this process, in the midst of this Laurasia and Gondwana, a new sea formed is called Tethys Sea. Sea. Okay, and in the third stage, Jurassic age, that is 145 millions of years ago, so continuation of the drifting of the continents begins faster and they are going distant. You can see this is India, Australia, Antarctica, Africa. This one is small one. This small one is Madagascar. This small is Madagascar. South Africa, South America, North America, Europe and Asia. So India is flying towards the Tethys Sea and will be merged or touches this Laurasian plateau. So during the Mesozoic era, the space between Laurasia and Gondwana filled with the Tethys Sea, and gradually got widened. This is in the next stage, fourth stage, Cretaceous, 65 million years ago. In this stage, the drifting goes faster. So the westward drift of the North America and South America, the North America and South America drifting towards the west and forming the Atlantic Ocean, the opening of the Atlantic Ocean, because we all know the ocean between North America and South America and Europe and Africa is called Atlantic Ocean. So in this stage, the Atlantic Ocean, the formation of Atlantic Ocean started, and the plates are moving towards the original position or the today's position. And the fifth stage, that is the present stage. Then the fifth stage, we can see the orogenetic stage. The orogenetic stage, where the mountains building activity took place. In India, the Himalayas forms, Andes, Rockies formed. So activities took place while the Himalayas and Alps were formed with the folding of the sediments of Tethys Sea. Here was the Tethys Sea. Indian plate came to the Laurasia and it merges with the Laurasian plate, and the formation of Himalaya begins here. So the Tethys Sea and westward drift of North and South America lead to the folded edges of the formation of Rockies and Andes. Rockies and Andes, mountains of the North America and South America. After that, we need to know the geological time scale. So geological time scale means the time calculated by the carbon method. So the geological time scale divided in two parts. First is Precambrian Superion, that is about 4.5 billion to 541 million years ago. There is three parts: Hadean era, Archean eon, and Proterozoic eon. Hadean eon, Archean eon, and Proterozoic eon. And the next is unnamed super eon, that is about 545 million years ago to the present. So that is called Phanerozoic eon. Phanerozoic eon, that is about 541 million years ago to present. This Paleozoic age divided in some parts: the Cambrian period, the Ordovician period, the Silurian period, the Devonian period, the Carboniferous period, and the Permian period. In the Carboniferous period, the formation of coal, that is related to the formation of coal. And the is Mesozoic era, that is about 250 million of years ago to 66 millions of years ago, divided in Triassic period. And the Triassic period also divided in three parts: early Triassic, middle Triassic, and late Triassic. Early Triassic epoch, middle Triassic epoch, and late Triassic epoch. And the important Jurassic period, also the part of Mesozoic era. And the last one, Cretaceous period. Cretaceous period is the last period of the Mesozoic era, that is about 145 million of years ago to 66 millions of years ago. And the last stage is the Cenozoic era, that is about 66 million years ago to the present. In this stage, the categories are Paleogene period, Neogene period, and Quaternary period. So Paleogene period divided in three parts: Paleocene epoch, Eocene epoch, and Oligocene epoch. And the Neogene period divided in two parts: Miocene epoch and Pliocene epoch. And as the same, Quaternary period divided in two parts: Pleistocene epoch and Holocene epoch. So the Holocene epoch is the last one, the part of Cenozoic era, where the present formation of the earth comes. Okay friends, so this was the end of the today's class. In next section we will study the forces responsible for the continental drift, evidences for the continental drift theory, just like jigsaw fit, rocks of the same age across the oceans, tillite, glacier deposits, fossil evidences, botanical evidences, distribution of fossils, etc. So thank you very much friends. Jai Hind.